Okay, so we had talked about the difference between a sentence and a word equation. And a sentence has things like a capital letter at the front and a period at the back and subjects and objects and verbs and all sorts of other parts of speech that if you're so inclined you can identify. I will not. When we make a word equation, of course, we just write the names of all the things in the sentence. So let's do this one for practice. Sodium carbonate, Na1 plus, CO3 1, whoops, CO3 2 minus. So Na2 CO3. Oh wait, what did I do? I skipped right over word equation. Sorry. Gotta watch me every second. We were writing a word equation for this. We're not there yet. Okay, if we're writing a word equation for this, we're just going to write the words. And I'm going to kind of condense these to make space. Sodium carbonate, and we know this is aqueous, so we have to write it. Reacts with aqueous calcium nitrate. So, Gesundheit. Calcium nitrate, aqueous, to form aqueous sodium nitrate and solid sodium carbonate. So aqueous and solid calcium carbonate. Okay, that's a word equation. Notice, no period, no capital letter, no verbs, just the names of chemical compounds with symbols. Pluses and arrows, and you do have that state information. So then, once we've got a word equation, we're ready to move on. So we're going to borrow this, copy. The easiest thing in the world to do is take that word equation and simply replace every word with a chemical formula. And of course, when we do that, we no longer have a word equation. What we now have is what's called a formula equation. Okay? So we'll stick that there. So if we're going to make a formula equation for this reaction, we have to write a formula for each of these things. So here's where we start with formula writing. CO3 2 minus, Na2 CO3, and that's aqueous. We have to remember to keep that information. Calcium nitrate, Ca2 plus, NO3 1 minus, Ca, NO3 2, and that's also aqueous. Yields, or reacts to form. So we have sodium nitrate, Na1 plus, NO3 1 minus, Na, NO3. Do we have state information? Yep, then we got to include it. And then our last one, calcium carbonate, Ca2 plus, CO3 2 minus. We get Ca, CO3. What's our state on that one? Solid. Looks more like the letter 8, but it's not, I assure you. There. That's a formula equation. It's not balanced. It's not giving you relative amounts. All it's giving you is the formulas of the substances that are reacting. We actually use these fairly commonly in biology. When you had biology, there were two basic equations that you learned about, photosynthesis and cellular respiration. And when we give you the photosynthesis equation, we say, oh, yeah, CO2 plus H2O plus sunlight yields C6H12O6 plus O2. Is that balanced? No. It's a formula equation. You know, it's just a formula equation. And actually there are like 400 little sub-equations that happen. It's a multiple step process, and that's just the overall thing. You'll learn it if you take a year of college biology. It's horrible. But we use formula equations to just represent, hey, these are the chemicals that are reacting. It's not a balanced equation. Let's get rid of this guy. Okay. So now, from this point, what do we have to do? Well, we have to balance. Okay, it keeps kicking me out. There we go. So, you all balanced equations in physical science, yes? To a greater or lesser degree. Some teachers spend, Mr. Stubbe and Mr. Voorhees spend a lot of time on it. I mean, it is hammered. If you had Mr. Stubbe and Mr. Voorhees and you were awake and working, you balanced equations. If you were not awake or working, if you were like a squirrely freshman and it wasn't your best year, you'll have some brushing up to do. That's okay. We can brush you up. So, you understand conceptually that the big idea is here that the same number of atoms of every element have to occur on each side of the equation. That's the big picture concept. Where are you with a scale, you know, on a scale of 0 to 5? 0, what's an atom? Who are you? 5, yes, duh, of course I know that. Same number of atoms have to appear on either side of that little arrow. 0 to 5, hands up. Okay, it's okay to not be a 5. That's what I want to know. If you're not a 5, it's okay. We're gonna spend time making sure you're at a 5. Okay? But I don't want to dive in at 5 level if I've got a bunch of people sitting there going, yeah, I'm not so sure about that. That's okay. It's fine. Okay, well then let's talk some more about that. When we take any equation, we know we can't create or destroy atoms, right? That's a 5, right? Can't make them up, can't generate them magically, and you can't disappear them. If you start with them, you have to finish with them. Well, what that means is that we have to start with the same number of atoms being shown on either side of the equation. Okay? The numbers have to match. You're basically doing tallying math. You're keeping score. And for those of you who have siblings, the whole drive to have it all be even. She got 3. I want 3. You know, whatever you people do. Imagine these as two siblings who are desperate to have even piles of chocolate chip cookies or something. I don't know. Yeah, got to have the same number of every single thing on each side of the equation. So we're going to walk through some examples. And what I'm going to share with you is my method for balancing. It is something that, you know, I've never seen it in a textbook or anything else, though I don't think it's anything revolutionary. Like, I don't think I get an award for it. It's just what I've come up with because I used to struggle with this. And so it's just a very step-by-step methodical way to do it. We'll kind of skip over these slides because really I just want to kind of discuss it with you. So let's use this as a start. Okay? The way that I balance an equation. So remember, what kind of equation is this? Word or formula? That's a formula equation. When we're doing balancing, you always need to recopy that formula with a little dash in front of each chemical. Okay? Reason being, on your test for this chapter, I will give you sentences, and I will say, give me a word equation, a formula equation, and a balanced chemical equation. Can't tell you the number of people who've lost 2 points on every single one because they took their formula equation and just balanced it right there. Recopy it so you have the formula preserved, and then you have what you're balancing on. Oops. Okay. The next thing that I do is going straight down from the arrow and make a line that divides the world. Everything on one side of the line are your products, that's what went into the reaction, or your reactants, that's what went into the reaction. Everything on the other side of your line are your products, that's what comes out of the reaction. And now we're just going to make a tally list. This is just like keeping score. So I'm going to list every kind of atom that I have on each side of the equation. So I've got sodium, carbon, oxygen, calcium, and nitrogen. I don't need to list this oxygen again because it's already listed. Okay. Do you see where I'm getting those? So I'm going, okay, I've got sodium, I've got carbon, I've got oxygen, I've got calcium, I've got nitrogen. Oh, I already listed oxygen. So I'm looking at each individual type of atom. And then I'm going to make that same list on the other side of the divide between the worlds. Actually, I might move that down a little bit. And now I'm going to count up how many of everything I actually have to start with. Okay? So you have to pay attention to both, well, to subscripts, inside and outside parentheses, all that. Well, I've got 2 sodium. Let's see, how many carbons do I have over? And we're only counting on each side right now. So I've got 1 carbon. There's 3 oxygens, and there's 6 oxygens. I have 1 calcium, and I have 2 nitrogens. Okay, do you see where those numbers are coming from? Okay. Do the same thing on the other side. 1 sodium, 1 carbon, 3 and 3 is 6 oxygens. I have 1 calcium and 1 nitrogen. Okay, this one's pretty easy. So in a case like this where you've got 2 compounds and they're just kind of switch and dance partners, it doesn't much matter what you try to balance first. Some things are already balanced. The first thing I see that isn't balanced is sodium right at the top of the list. Yes, ma'am. Oh, you know what? You're right. That's 6. That's 9. Thanks. Good catch. I'm going to, yeah, fix that. Sorry. That's 9. Yeah, make sure that you're accurately tallying, unlike me. Okay, so we have 2 sodiums, 1 carbon. That's 3 oxygens because that's CO3. Well, here I've got NO3 twice. So that's 6 more oxygens. So I have 3 oxygens here, 6 oxygens there. So I have a total of 9 oxygens. I missed that. Sorry. Okay. So if I wanted to balance out my sodium, is there an easy way to get 2 sodium on the product side? Remember, you can only change coefficients. Well, if we stick a 2 here, and then we have to go through and update our totals for everything. This is my Moser's patented method of madness. Update your totals, leave the number you had and just put a single line through it, and put in your updated number. So that changed our sodium. That also changed our nitrogen. That also changed our oxygen. So now we have 6 and 3. That's now 9. Hey, guess what? We're balanced. That wasn't so bad. Now I'm going to show you a trick, a shortcut on a problem like this. Okay? And I don't know if anybody's ever talked with you before. I I don't know if anyone has had the talk with you about leaving your ions together. No? Okay. In a situation like this carbonate ion doesn't break up. This nitrate ion doesn't break up. So we can actually leave those ions and balance those. So let's look at what that would look like. Get rid of some of my marks here. Okay, let me get rid of my little check marks. Okay, so instead of doing every single atom individually, because those ions stay in ionic form, that carbonate ion doesn't break apart and form carbon dioxide and oxygen gas or something. I can say, okay, I've got sodium, well, I've got carbonate ions, I've got calcium, I've got nitrate ions, and I've got the same thing over on the other side. This is a nice shortcut in complicated equations where you've got a lot of polyatomic ions together. It's a nice way to keep life simpler for yourself. So we're going to do the exact same thing that we did before, but now instead of counting individual atoms, we're just going to count the polyatomic ions. So, okay, I've got 2 sodium. How many carbonate ions do I have on the reactant side? 1. How many calciums? 1. How many nitrate ions do I have? 2. On the product side, I've got 1 sodium. How many carbonates? 1, 1 calcium, and 1 nitrate. Okay? Do you see where those numbers are coming from? Okay. Is there an easy way to get 2 sodiums? Update my totals. That also gives me 2 nitrates. Hey, look at that. Less counting. Okay. So what I have for you is a practice sheet. I have 2 practice sheets, actually, on balancing chemical equations. They will be due on Tuesday when we come back. They're 10 points each. And then you'll have a FIP Tuesday when you come back. The practice sheets focus more on going from a word equation to a formula equation to a balanced equation. On your FIP, though, you will be expected to be able to go from a sentence to a word to a formula to a balanced and provide all 3. Okay? So just right now, a lot of people in the other class chose to focus their practice on making sure that you can get from formulas to balanced. But make sure that you remember that on your FIPS and then on your test, you'll have to do all 3. It was a little bit freaky. A couple quick reminders before you start the practice. If you've got a metal, like sodium or iron or magnesium or calcium, and it just says that you have magnesium. What's the formula for that? Just Mg. Because angry metal guy walks alone, not holding anybody's hand. If you come across something and it says hydrogen, hydrogen on its own appears in what form? H2. So be really careful with the things that are diatomics. The other things, if you look at your ion Bible, there are, here, you know what, let's do you want to do one more together before I turn you loose? Let's do one more together. Okay, this is one that we actually typically do in the spring when we do gas law stuff. So, magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. Okay, so that's our sentence. Making sure that period's on the end. So where do we start? And this is the step on your practice sheets. You'll be starting at this step, which is word equation. Why start with a word equation? Because you screw up less if you start with a word equation, because it just breaks everything down and isolates it for you. So, magnesium, recording this, hydrochloric acid. Oh, well here we're just writing it so it doesn't matter. Forms magnesium chloride plus hydrogen. Pardon? Ah, we're getting to that. Good question. Okay. So, you weren't given explicit state information in this sentence. This was the other question that came up on the practice problems. Well, I don't expect you don't have to pay attention to this in the practice stuff, but you should know by the end of this chapter, oh, if it's a metal and you're just giving me a metal, what form is that going to be in? It's going to be a solid. Because metals are solids at room temperature. They're solids and they can be monoatomic. So that would be a solid. You don't know this yet, but you will, and you'll know it really well by the end of chapter 14 and 15. Anytime you are given acid, like hydrochloric acid, sulfuric acid, nitric acid, bromic acid, those are always aqueous solutions. So that means that you've got the molecules dissolved in water. So that's always aqueous. The magnesium chloride, you at this point could not predict the state that that's going to be in, so you can't really say anything about that right now. I can tell you it would be aqueous. And hydrogen, we'll just do this and then you can go take your 4. Hydrogen at room temperature is what? It's a gas. So that's going to be gaseous. Okay, go take your 4 minutes and we'll come back. Okay, so when we last left our chemistry heroes, we were talking about the fact that the states, some of them you can kind of infer from what you know, and some of them you would have to be given. And I wouldn't worry too much about it on the practice sheet, other than just starting to get used to doing that. So now we have to write formulas. Well, magnesium, it's a metal. What's its formula? Mg. And that's a solid. So that's done. Hydrochloric acid. Ooh, good. Some of you know this. Bottom of your ion Bible, there's a little box that says common acids. HCl. Yes. And that's HCl aqueous. Okay. Magnesium chloride, that's one that you can write. I'm just going to make my little note to myself. Mg2 plus Cl1 minus. MgCl2. And I can get rid of all my little notes to myself. And for that one, you were given state information. I wouldn't expect you to infer that yet. By chapter 14, you'll be able to figure that out. But you can't yet. Okay. And hydrogen, what's the formula for hydrogen? H2, good. And that's gaseous. Whoops, I don't even know what I was writing there. Okay, so there's our formula equation, and we're going to take this over to the next page to do our balancing. So, you know, I'm going to keep recommending to you that you recopy that with some spaces to put in coefficients. Okay. So we now have an equation that we're ready to balance, and we just want to do our tallies for all of the elements that are present. Okay. How many magnesium we got? 1. What about hydrogen? 1. What about chloride? 1. How boring. Okay, on the other side we've got 1 magnesium, 2 hydrogen, 2 chlorine. Well, this one's pretty easy too. Any way that we could get 2 hydrogen and 2 chlorine on the reactant side? Yeah, so one number fixed. So we put 1 in here, that becomes 2, that becomes 2. And those are the kind you can almost do without a whole lot of fanfare. The ones on the practice sheets, that will not be the case. Yes, ma'am. And you know what? You can leave this as your final answer. I don't care. What would more traditionally be done for a final answer? Whoops. Copy that. What would most traditionally be done, like if you were in a college chem class, you know, you would write, oh, well, MgS plus 2HCl aqueous yields MgCl2 aqueous plus H2 gaseous. So you would rewrite it like that. But for here, for now, I don't much care. If you want to get in practice doing that, you can. Okay, so this is number 3 on your first practice sheet. And we're going to talk more next week. I forgot to look at your learning goals with you. But one of your big ones for this week is being able to write and balance chemical equations. That's what we're working on right now. Next week you'll start classifying reactions into different reaction types. And number 3 is the combustion of a hydrocarbon, which is one of the reaction types we're going to talk about next week. So this is your first combustion of a hydrocarbon. Oh boy! Things that go boom. So what we have, and we're given the word equation here, and we're just going straight to formulas. So we've got ethane, C2H6, and that would be a gas, plus oxygen. What's the formula for oxygen? O2. Good. And when we put those together, they form CO2. What's the formula? Oh, I said it. Sorry. Ooh, boy. Okay, gaseous CO2 and water. And that's also gaseous. Okay, so we're going to recopy that for the purposes of balancing. We got 3 elements. How much easier could this be? C, H, and O. So let's do our first tally, our preliminary tally. How many carbons do we have on the reactant side? 2. How many hydrogens? 6. How many oxygens? 2. On the product side, how many carbons? 1. How many oxygens? 3. Good. You have to be really careful. There are 2 oxygens here, but there's another one over here. And that makes balancing these a little bit trickier. So we have 3 oxygens. I'm sorry, I skipped to the oxygen. I missed the hydrogen. How many hydrogens? 2. Okay. So a couple of things that we realize immediately. Can we ever, well, let's start with this idea. When you've got something like this oxygen that's all by itself, save balancing oxygen for last, because that's basically your dustpan. That's your tying up loose ends kind of thing, because all you have to do then is put any coefficient in front of it. When you change the coefficient for that gaseous oxygen, it won't change anything else. And, you know, it's an easy... you guys do look miserable. I'm sorry, I'm just a lot. Okay. So, first things first. We're going to leave oxygen for last. What do you know, however, about the number of oxygen that you're going to have on the reactant side? It will always be Even. Right? It's O2. Doesn't matter what you multiply O2 by, you're going to get an even number. Well, here you've got this H2O that has one oxygen. So whatever coefficient you have in front of H2O also has to be what? Even. You can't have an odd coefficient in front of H2O. So that's just something to note, okay? And if you forget that, trust me, you'll get enough practice, you'll pick right back up on it. Let's start off by trying to balance our carbon, shall we? Okay, top of the list. So how could we get 2 carbons over here? Well, we stick a 2 there. Then we update our totals. We have 2 carbon now. Now we have 4 oxygen plus 1 oxygen. We're up to 5 oxygen. Okay. Well, what about hydrogen? Could we get 6 hydrogen on the product side? How? What coefficient would we need to get 6 hydrogen? 3. But there's a problem with that. What's the problem? You can't have an odd number there because that's going to give us an odd number of oxygens. How could we make a multiple of 3 even? Double it. So let's put a 6 here. Okay, update your totals. That's 12 hydrogen. That's 4 oxygen plus 6 oxygen. That's 10 oxygen. Okay. So far, so good? Okay. Well, now let's see. Our carbon's balanced, but our hydrogen isn't. If we go back to our reactant side, is there a way to make that 12 hydrogen easily? Yeah. Put a 2 in front of our ethane. So let's update our totals. We have a 4. We have a 12. You see how? So 2C2H6 gives us 4 carbons and 12 hydrogens. You see that? Okay. Well, now we're back to having to balance carbon again on the product side. And this is how it goes. You know, you tinker with this, it changes that. You tinker with that, it changes that. You tinker with this, it changes that. And you go back and forth and back and forth. This is why I picked this one to do together, because it's a good example of that. So let's finish this one and I'll talk about traps that you can fall into. Okay, so can we get our carbon back to balance? Can we get 4 carbons on the product side? What would we need to do? Replace that with a 4. So now let's update our totals. Hoya, hoya, hoya. 4, that gives us 8 oxygen plus 6 oxygen, that gives us 14 oxygen. Hey, look at that. Everything except oxygen is now balanced. Do you see that? Is there an easy way to get 14 oxygen? Stick a 7 there. And now we have 14 oxygen. Okay? The trap that you can get into with that tinker here, tinker there, tinker here, tinker there, is what I call the upward death spiral. Until you've got, you know, like 58 carbon, 643 hydrogen, and 96 oxygen. Hey, did I do something wrong? Possibly. We do a few equations where you get really huge numbers. That's okay. But the other thing to check when you're done, can those coefficients be simplified? Just like with your formulas, like if you had, you know, SN2O2, you would simplify that to SNO. Check those coefficients. If you had, you know, 2, 6, 2, 4, you need to simplify your coefficients. You went too far. Can we simplify this? No. That 7 is prime. We can't divide that 7. We can't have 3.5 oxygens. Okay? Reasonable? Sensible and logical? Okay. I'm going to float around while you work on the worksheet. The keys will be up by the end of the night tonight. What I'll do is take pictures of them and put them on PBWorks. I'll put them right on the Chem Daily page. And so you can check your work. They're due when you walk in on Monday. And you'll have a FIP on this stuff on Monday. Questions, comments, concerns? Cookies? No, because I'm just going to look at it on Monday and say, yes, you did every problem. It's just the practice sheets. The FIP we might actually do in class. We'll see. We'll see where we're at. So, okay. Nothing more. Start working.